Alright, so looking at 3.3, we're going to answer a few questions, three main questions today. One is, how do we deal with multiple logarithms in the same expression? You know, log of this plus log of this minus log of this. Alright, we've got multiple logarithms in the same expression. Okay? The short answer is we're going to condense them down into one logarithmic function. Second question is, how do we deal with the logarithm of an expression? You know, we have log of, and it's not just the log of x, it's the log of x squared plus 3x minus 5, or something like that. How do we deal with that? So how do we deal with the logarithm of an expression? We're going to expand it to the sum or difference of multiple logarithms. And then, finally, how do we evaluate logarithms that have a base other than 10 or e? And this would be particularly without an n-spire, because the n-spire asks you for a base, but those of you with the 84s and 83s, your calculator cannot do a log base 3 or a log base 7. Okay? You have to understand how to do that. And for that, we're going to use our change of base formula. Even if you have the n-spire, though, the change of base formula is helpful in rewriting certain things. Because you know, in certain instances, rewriting it can help us solve it a simpler way. Okay, so let's get into this first of all by looking at a couple of the properties. Okay, there we go. All right, a couple of the properties. The first one is the product property. The product property says that if we have the log of two things multiplied together, we can expand that into the log of one plus the log of the other. Okay, I used m and n to represent the two different things. And these properties do work both ways. If you have the sum of two logs, you can write it as the log of those two things multiplied together. If you have a log of a product, you can split it into two different logs added together. Okay? So, for example, looking at it both ways, if I had the log of 3x, I could take the log of 3 plus the log of x. How might that be helpful? Well, I could do log of 3 on my calculator now. And now I just have to deal with the x part. Another example here, if I have the log of 5 plus the log of x plus the log of 2, I can multiply these three things together. 5 times x times 2 is 10x. I could write that whole thing as just one logarithm. And you guys will see as we move forward how in certain instances, it's going to be helpful to condense it down into one logarithm. And in other instances, it's going to be helpful to expand it out into multiple logarithms. So, let's try this. If I have the log base 2 of x plus the log base 2 of 3 equal to 8, if I were trying to solve this equation, the first thing I would want to do is just get one logarithm on the left-hand side. Okay? So how could I rewrite the left-hand side?
Log 2 3x.
Very good. The log base 2 of 3x. Now, I can translate that into an exponential. Okay? How could I rewrite this?
8 to the, or no, 2 to the 8 equals 3x.
There we go. 8 is the exponent of 2 that gives us 3x, right? That's what that means. 8 is the exponent of 2 that gives us 3x. So we're kind of just rearranging it into an exponential. Now, you have an equation that you can very easily solve. Okay? 2 to the 8th is 256 divided by 3, and you get 85 and 1/3. Okay?
That's annoying.
It's a fraction. So. Okay? Now, we'll look more at solving equations tomorrow. You already had a preview of that. But that's one of the uses here. Okay? Are there any questions so far? All right, good. So then we have the quotient property. Before I show this one to you, let's think about this. Remember, logarithms give you exponents, right? When you had the same base and you multiplied things together, what did you do with the exponents? You added them, right? We're multiplying two things together. We add the exponents. Isn't that what we're doing here? Okay? What do you do with the exponents when you're finding a quotient? A quotient is what operation?
Division.
Division. Okay? When you're dividing things that have the same base, you subtract the exponents. So, the log of m divided by n is going to be?
Log of n minus n. Log
There we go. The log of m minus the log of n. It relates directly to those exponent rules that you learned way back in 6th or 7th grade, probably. So a couple of examples here. The log of 3 over x is going to be the log of 3 minus the log of x. Okay. The log of x minus the log of 2, we could rewrite as the log of
x over 2.
very good, x over 2. So here we have one that we expanded into 2 logs. Here's one that we condense into 1 log. Then we've got this one here. We have 3 parts to it. The log of x minus z minus 3. That is z. No, I don't know if that's a z or a 2. We'll find out. Anyways, what would we do with that? To put it all in 1 log.
X minus. Is that a 2 or a z?
I think it's a 2.
You just
It'd
make
be
a
x
big
over 2
fraction.
over 3.
It'd be x over 2
Over
over 3, right?
Or Z.
or whatever.
I'm pretty sure that's a 2. So, alright, x over 2 over 3. Now, how would I simplify that? I don't want you leaving complex fractions like that.
3x.
No?
No.
Does it matter which order that
X
you go in?
divided by 3 over whatever 2/3 is a decimal.
No. Order of operations says we have to do x divided by 2 first, then divided by 3.
0.5x.
What?
Yeah, half x,
Half of x over
0.5 x, yeah.
That's what we have for
Well, we don't want to do 0.5x over 3. What were you saying?
No, it's not.
3x over.
If you're dividing by 3, that's the same as multiplying by a third. So what's x over 2 times 1/3?
6.
6 of x X over 6.
X over 6, okay? Here's a little tip. Anytime you have something, a fraction that's just being divided by an integer, okay, you could just multiply that by the original denominator,
I said that.
and that's your new one. I didn't hear you.
So does it matter which order you go in?
He didn't like
So-
X 2 over 3 over X.
In this case, actually, no, it doesn't. If you had the minus log of 3 before the minus log of 2, you'd get the same thing.
Excuse me, how did we get the X over 6? We just multiplied 3 and 2, that's it?
Yes, because x over 2 divided by 3, that's what that is, right?
Oh, okay.
Is the same as x over 2 times 1/3, which gives us the x over 6. Okay? Alright, so let's work our way through solving this equation here. The log base 3 of x minus the log base 3 of 5.
Log base 3 of X over 5.
Alright, the log base 3 of x over 5 equals 2. Now we can rewrite it.
Log base 3 of 2 is X over 2.
There we go. Good. 3 squared. 3 is going to be, if we're rewriting it as an exponential, we have to use the same base. So 3 to the second power equals x over 5. Remember, 2 is the exponent of 3. That gives us x over 5. Then, again, you're down to a really simple, okay? You're down to a really simple equation to solve. Alright. 3 squared equals x over 5. 9 times 5 is 45. We have any questions about that one? Okay. Alright. There is one more, and this is one that a couple of you mentioned earlier. It's the power property. Okay? The power property. The log of m to the k power equals k times the log of m. How did you simplify that back in Algebra 1?
Multiply the,
And power.
You multiplied the exponents, right? So 2 times 5, you get x to the 10th. Well, here, we've got a logarithm. We're finding the exponent of something that's already raised to an exponent, right? So, you multiply your exponents. Here's the exponent from the m times the exponent of m. Alright? It relates again right to those rules from polynomials in algebra. Okay? So, well, I'll leave that up there. So, if we have the log of x squared, we could rewrite that as 2 log of x. If we have something like 4 times the log of 2, okay, I could rewrite that by putting the 4 back in the log as 2 to the 4th and simplify it down to the log of 16. And if you used your calculator and figured out what 4 times the log of 2 was, and then figure out what the log of 16 was, you'll get the same thing. Alright, it's just a different way of writing it. The log base 4 of x to the 4th equals 16. If I were solving this equation, you could do this one of two ways. And this is where this rule actually can really come in handy, okay? Think about this. If I rewrote this as an exponential, instead of using my power rule, I would have x to the 4th equals
16, 4 to the 16.
4 to the 16th power, okay? Now, that gets really huge, alright? 4 to the 16th power. If you punch that in, chances are your calculator is going to give you something in scientific notation. So even it is not going to give you an exact answer. However, let's think of it in terms of this rule. How could I rewrite this?
Log 4x equals 4.
Yeah, 4 times the log base 4 of x equals 16. Okay? Now, divide by 4. The log base 4 of x equals 4. So what am I evaluating now?
X equals 4 to the 4.
X equals 4 to the 4th. That, while it's still a little bit bigger, it's not too bad. Okay? It's not too big. 4 to the 4th, 256. Okay? Would you get the same answer eventually? Sure. But this one, our numbers stay much smaller. Okay? This one we'd have to take the 4th root.
Excuse me, we can just simplify that one. Just divide everything on 4, like the power. Can we divide the power on 4?
Well, you can't divide the power by 4. What you'd end up doing, you'd have to take the 4th root of 4 to the 16
Oh, okay.
and the 4th root of x to the 4th. And that would give you just x. This would actually divide 16 by 4 and leave you with 4 to the 4th. Okay? So it's not that it's impossible to do this, but if you tried to do that on your calculator, it's going to give you way too big a number.
Mhm.
So, alright. So again, just a way that you can use that rule to help you. Okay? So, what I'm going to have you do is I'm going to give you just a couple here to try to expand. Okay? There's 2 here to expand the log base 4 of 5x cubed y, and b is the natural log of the square root of 3x minus 5 all over 7. Just to help you get started with b, what exponent is a square root? 1/2. 1/2. Okay? Take a couple minutes. You're welcome to work with the person next to you, if you'd like.
Are you supposed to do one? Do you? Oh, just expand.
Just expand it. Yep.
Okay, so. Is this right? Expanding.
Okay. You can actually do something more with that middle one. That's correct so far. You can just do a little bit more.
Is this correct?
Not quite. The 3, only the x is cubed. So it would only go with this. And you lost your 5 in there.
You're right.
That one's good. That's good so far. Keep going with that one. You can
How do you
simplify that one.
expand? How do you expand this? Do you just multiply like this 3 per 4 usually?
Yes.
Or
don't want you to see it yet.
Wait,
But I
what's
think
there?
it-
Did you just write it like?
It's showing up on the screen, but it's not showing up on what you can see yet.
Wait,
So,
I'm getting the last one is just ln 3x minus square root of 3x minus 5 minus 7
I can see what I'm writing.
you can keep going with that.
ln 3x.
Okay. Just take it one step, keep going with it.
No offense.
It's the same
Mhm.
things though.
So, like, say you're like,
So yesterday I was eating pizza with him and
I'm so hungry. I should
Okay.
have really quick.
Yeah, we
I'm
can't.
like, I'm gonna get my ankle rubbed out. I'm really scared.
When it's already subtracted in there, you can't simplify that more. Okay, so the best you could do. Let me show you what we've got so far here. See how it came out.
She's so, I think she's so cute.
I almost got it without running into it.
Oh, because it's square root of half.
Okay, you could take it that far.
Oh, I did that.
All right.
Exactly.
The best you could do beyond that. The best you could do beyond that would maybe to be to factor out a 3. If you really wanted to expand it more, you could do 1/2 times. It'd be the natural log of 3 plus the natural log of x minus 5/3 minus the natural log of 7. Okay. But if you stopped here, that would be sufficient. Okay? So, look at part A. Part A, we've got the log base 4 of 5 plus 3 times the log base 4 of x. And notice the exponent there came out in front plus the log base 4 of y. Yes?
It's on a test. Do you want us to stop once we have that binomial, or would you want it broken apart so that it's just x?
No, and in fact, this one there's no way to really get it just down to x because.
Well, no, I mean like from 3x.
Oh,
do you want us
no,
to
you
get
can
rid of
stop
coefficient?
right there. You can stop right there. It's possible to go a little bit further, but it's not really.
Just it, like is
doing
that
anything
considered
for us.
better to then go?
No. No.
Just like,
Okay? Does anyone have a question about how we expanded any of those? Okay, let's do the same thing, except condense. So here's 3 of them to condense. Alright, you should be able to write each of these as 1 logarithm. Okay, condense it all the way down to 1 logarithm. Okay, can everyone read it?
Do you have to get rid of the 3 and the 1/2 in front?
Yes, there shouldn't be a coefficient in front. It should just say log base 10 of some mess. Okay? B should be natural log of just one thing.
oh, yeah.
So would it be log of x to the half x plus 1 is 3?
Mm-hmm. And then what, just to simplify that, what is something to the half power?
Square root.
Square root.
Square root.
So log square root of x plus 1 to the 3.
actually came out halfway decent.
Okay. And then
Plus log.
but you have to put it into one.
And how do you do that?
You can multiply, if they're multiplied, then they're the same thing as addition.
Yeah.
F is plus F, so I just put square root of X and
Oh, I got it. Oh, I got it.
Because I put the distributed in. Oh wait.
And since they're both cube roots, you can put it on one big cube root.
That's really funny.
Alright, let's check our answers here. What do we get for A? One person raise their hand and give us an answer for A. So we don't have a lot of people. Danielle?
Okay, I got log base 10. I don't know if this is right, by the way. X plus 1 to the third square root x. Would
Alright.
it be like moved around?
I
Yeah.
just square root of X.
And you could put the square root of x in front of the x plus 1 cubed, or you could put it after the x plus 1 cubed. It doesn't matter.
Gotcha.
Okay? Alright, so good. That should be our answer for A. And by the way, they put log base 10. You don't have to write log base 10. Because that's our common log, right? So, I don't write the base unless I have to.
Oh, it's minus.
Would it be wrong if we did that?
Okay, how about B? Someone want to give their answer, Michael?
Natural log x of x plus 4 plus 4x. 4 divided by x.
Wait, say the whole thing again.
Natural log of x plus 4 divided by x.
Did you square it?
I think you got the right idea. It should be x squared plus 4x plus 4.
Well, yeah, I had that, but then divided by x.
Oh, you split up into 3 separate
Yeah.
terms. Okay,
'Cause-
that'll work. You don't have to go that far. You did x plus 2 squared, and that whole thing is over x. Okay?
Yeah, that's
And then what he was saying he did is he
X
squared it, x squared plus 4x plus 4, and then each of those is over an x. So if you simplified it would be x plus 4 over x, all in the natural log. Okay? That is correct. That is sufficient right here. Okay? You don't have to go past this. Okay? So. Okay? How about C? Ada?
Log base 2 to the square root of 3x squared minus 4x.
It's not square root, it's cubic.
Oh yeah, cubic root.
Okay. Good. It's the log base 2 of the cube root of x times x minus 4, which is x squared minus 4x. Okay?
Oh, because
Alright? Yeah, the 1/3 gives us a cube root, and you multiply those two together. So you could leave it as x times x minus 4, or you can multiply it x squared minus 4x. Yes?
Why is it natural log? Or whatever that's
Oh, because I was stuck on B.
called. Okay.
Sorry. Thank you. That should be log base 2. Thank you. Alright. So, do we have any other questions about expanding or condensing? Okay. Now, I want to look at something that we've mentioned. We've mentioned this in the past, but I want to actually look at it formally and look at using it here, okay? And that is the change of base formula, okay? The change of base formula. So we have here the log base 2 of 9 that we have to evaluate, and we don't have a calculator that can do it for us, okay? So we have to change the base to something our calculator can handle. So what the change of base formula says is that you can change the base to whatever base you want. Okay? As long as you put it in this ratio. The log base b of a can be converted to a base of c if you take the log base c of a and divide it by the log base c of b. Okay? So here, we're converting the base from b, don't do that. There we go. Converting from base b to base c by setting up this proportion, okay? Now, typically, we will convert to either e or 10 because that's what our calculator can do, all right? But I'm actually going to skip to the last example here. You don't have to skip to E or 10, or change to E or 10, because look, if I had the log base 8 of 16, these are both powers of 2, right? I could change it to base 2. The log base 2 of 16 over the log base 2 of 8. Well, 2 to the 4th power is 16, 2 to the 3rd power is 8, so this equals 4/3. Okay? So before we get into using it where we're doing things that we can do on our calculator, just be aware you don't have to go to base 10 or base E. This works for any base. Okay? So, we have the log base 2 of 9. So how would I do that on the calculator?
Log, yeah, just, I would do common log.
Okay, common log of
9 over log 2.
okay. The common log of 9 over the log of 2. So we can punch that into our calculators. It'll give us an answer. 2 to what power is 9? Well, I know 2 cubed is 8, so I should get 3 point something, right? So what do I get? 3 point what? 17? Okay. 3.17. Okay. Do be careful, and this is where those of you without your calculators out, you need to get them out, okay? Make sure you're punching them in carefully. When you punch in log of 9, your calculator does this. So then you punch this in. Is your calculator going to do what you're trying to tell it to do?
Oh, you have to put a parentheses after the 9.
Yeah. This one doesn't really matter because it's the end of the whole thing. But this one, you've got to have a closing parenthesis on. Otherwise, you're not going to get the right answer. It would do 9 divided by the log of 2 and then take the log of that. Okay, so be careful that you're punching things in correctly. Alright? Try the log base 8 is 16. .33333, which is 4/3, right? But you're punching in the log of 16 over the log of 8. Okay? Now, just to show, this works with any base. So if you hit log, that's fine. If you did the natural log of 16 divided by the natural log of 8, it would still give you 4/3, okay? The key is just make sure you use the same one in the numerator and in the denominator. Okay, don't mix them up. Okay. All right. So, why do we learn this? Well, because in most of our applications, we're not going to end up with a base of E or a base of 10. Okay. Now, we do end up with E actually more often because continuous growth is E to some power. We saw that with our exponentials. Alright? But for example, let's say we've got a school district who's trying to plan ahead for the future. Alright? They've been growing at a rate of 3% annually. Right now there are 10,000 students in the district. The current facilities can accommodate up to 15,000 students. So, when will we run out of room? We're solving for a time here, right? We're solving for a time. Let's set up an equation here. Our population right now is 10,000. So that's our starting amount, right? So our amount at a certain time is 10,000 times, how do we set this up? What?
3%, 0.03.
Is this like the P?
Close. It's similar to the principal and interest and that stuff, but it's like it's compounding annually.
So you still use E? Right?
No, it's compounding annually. So that n part is just 1, so we don't need to worry about dividing our rate or multiplying our
So it's
time.
like 1 over
1 plus something.
There we
Oh,
go,
there
that's
you
what we
go.
were looking at for. 1 plus the 0.03.
For our test, do you want us to memorize those?
Yeah.
This is the growth formula is something that you ought to be familiar with, okay?
Like memorized or familiar?
Yeah.
Like be able to read a problem and set it up. I'm not going to ask you to write down the growth formula. You should be able to set up a problem like this, okay? It's growing at a rate of 3% every year. I don't need to divide the rate by anything because it's growing every year, okay? And I'm wanting to solve for the time. We're going to do more problems like this, so don't get too nervous about it. So that's going to give me my amount at any given time. I'm going to solve it, the problem here, by plugging this in. 15,000 equals 10,000 times 1.03 to the t power. Okay? Yes?
I said 1.03.
If you just, because we're growing, you're still going to have the original 100% plus another 3% every year. Good question.
Sure.
Yes.
My calculator, when I do a division, it gives me this instead of a number.
Oh, okay. On the Nspire, you guys found that to be the case when you divide, it always gives you a fraction?
Yes,
Okay.
there is,
You hit the change button.
You can
hit the
convert it.
control and then you hit the control and then enter.
Control Enter,
Yeah,
okay? Or
and then you get,
when you type in your division problem, like he has 3 divided by 100, if you do 3 decimal point divided by 100, you don't even have to put 3.0, just put 3 decimal point divided by 100 and hit enter, it'll give you the decimal. So there's a couple of different ways. There's also a function that says convert to decimal.
And
Alright.
it makes it forever.
No, just for that step, okay? So how are we going to solve this?
Log.
Take the log of, or you divide by 10,000.
Aha, get the exponential part by itself first, divide by 10,000, so that should be 1.5, right?
Yep.
Equals 1.03 to the t power. So now what are we doing?
What? Log.
Log of 1.5 equals the log of t, or t log of 1.03.
No, log
I
One.
didn't follow that.
If you take the log of both sides.
The log of both sides, what log?
So log 1.03.
Yeah, a log with a base of 1.03, right?
Yeah, 1.5.
Because you gotta undo an exponential that has a base of 1.03.
Equals t.
Okay?
If you.
That gives me t.
Oh, okay.
And now, change your base formula. Okay? You can evaluate that with the change of base formula.
If you just take the common log of it, can't you move t like in front and then you just divide by 1.03?
I got 13.
Like the log of 1.03. Like,
Oh, you're saying do this.
well, yeah, the common log.
Log of 1.5 equals,
t log
You got
1.03.
yeah, you're using that rule log of 1.03,
And then you divide.
and then you divide.
And it's the same thing.
That's actually kind of how the change of base formula is derived, really.
Yeah.
You divide by that, the exponent is, and there's your change of base formula. Okay, yeah, you can do that if that makes more sense to you. But remember, the log is the inverse of the exponential with the same base.
And when we get a question like this, you'd want us to round up to the nearest year, right?
Well, what does it say?
13.7.
13.7?
14 years.
Want to be 13.
Well, when we're gonna run out of room before we get to the 14th year, so we could say, I mean, you could just leave it at 13.7 years. Okay, unless they ask you in which year will we run out of
And
room,
to the 13th.
you could say, you could convert it then. Like if it said it was starting in year 2010, you could say sometime in the year 2024. Okay, if that was the end of 2010 that they did this, sometimes near the end of 2000 or in the middle of 2024. Okay, because 23 would take you the 13 years, then you're somewhere in the middle of the year 2024. Okay, so just be careful, think it through. The main thing though is that we understand how long it's going to be. All right, are there any questions, comments, anything? Okay. So, I have one more, okay? This one's a little bit different. Suppose we invest at 9% interest compounded quarterly. How long will it take to triple our money?
Can you substitute anyone?
Yeah, you can have like 1 for
Yeah.
the starting amount and 3 for the end amount, right?
You could do that, yeah, and that's good thinking. We're not told a specific amount, right? So when I set up my formula, let's set up the formula. It's the principal times 1 plus 0.09 over what?
Quarter.
4.
4, good. To the
14.
4 times t power, okay? And you guys are right, we can plug in whatever we want for the original principal and just make sure that we set it equal to something triple that. Or,
If I start with $0, my target is $0.
so remember that a cannot be 0, so. Alright, so I could also just do this. I'm starting with P and I'm ending with 3P. And I know my principal is not 0, so I can divide by P, and now I just have that equals 3. Okay? So you can plug in a specific amount, $1 and $3, or $1,000 and $3,000, doesn't matter.
How did you change 18 to 3?
Because we're looking for 3.
I'm plugging in to get triple.
Okay, so it's
Sorry.
3 times the principal.
Yeah, and then I just divide by whatever that principal was,
So
will
you-
cancel out. So 3 equals this part,
1.
okay? So 3 equals 0.09 divided by 4 would be 0.225 to the 4t. So how do we solve it?
Take the common. Oh,
You could take the log of 1. I mean, you make
Just
the
a
log
This is my bad shirt. So
1, 2,
is it a
5.
Or you divide?
Okay. We're taking the log base 1.0225.
is it okay if I just keep taking this?
You can do it however you want, as long as, since that's correct, alright? But, okay, the log base 1.0225 of 1.0225 to the 4t is going to give us our 4t. Okay? So now we just need to do the same thing over here to the 3. The log base 1.0225, and then you use your change of base formula. And I know it may seem kind of weird to be using a base of 1.0225, but that's just whatever the base of this exponential is what you're going to use for the base of your log. Okay. So what do we get?
12.4.
12.34.
is equal to 14. No, is equal to t.
Is
14,
equal to t.
49.37 is 14.
Oh wait, this
T.
is
This is
What, 49?
49.37?
Yeah.
Okay, and then, sorry, you got 12.34
34.
for T. So, a little over 12 and a third years, so about 12 years, 4 months. It's gonna take for our money to triple. Okay? So, that's not too bad. Yeah. But if you think about, you remember we looked at those exponentials and we saw that, like with the mortgage, over a 30-year mortgage, you ended up paying, well over double, even though you were paying it off along the way. Imagine if you just let the whole balance sit in there for 30 years. You'd be, if you paid it all off at the end, it'd be over 30 years. If it was 6% interest,
Which is crazy low.
it would be almost triple. Okay? Or no? 6 years, it would be doubling. So it'd be doubling every 12 years about. So it would be 7 to 8 times more than what you originally borrowed if you just let the whole balance sit in there for 30 years. At 6%. Alright. Anyways, are there any questions about how we set the problem up or how we solved it?
How do you plug a different base in? You can't do that in your calculator, right? You can't like plug in.
Not on the 83 or 84. The Nspire actually will let you plug in whatever base you want.
So that's how you got it.
Well, no, I did it using the change of base formula. We take the
Oh,
common
for
log
some
of 3 over the common log of this. You and I both end up doing the same thing mathematically in the end. It's just how we get there is a little different.
Yeah, I
That's
just got a
fine.
different answer, so. Oh, no, now I got it.
Okay.
Oh, I see what I did.
Did you lose the closing parenthesis?
I lost the, instead of 1.0225, I did 1.225.
Oh, okay. Yeah.
I threw it off by like a massive.
Yeah. All right.
May I ask you a question?
Yes.
When we rounded, should we put 13 years or 12.5 years? Because it is compounded quarterly, so we will get this amount at 12.5 years.
You'd have to look at the problem. This just said how long, so you
In
could
this
just leave
case.
it 12.34.
Oh,
If it asks for a specific year, if we invested it at the end of 2014, if you add 12 years to that, that would be 2016 plus another 4 months. Now we're into, or not 16, 26. Now we're into 2027, the year 2027. So if it said, in what year will our money be tripled? We could say in the year 2027. Okay. If it just is asking how long, then you can just leave it as a decimal part of a year. That's okay.
okay.
So. All right. I'm going to let you take the remainder of our time. Okay. We still have 20 to 25 minutes here. And I want you to practice. Now, if you look at the homework assignment, don't freak out, okay? There's a lot of problems listed, all right?
Just take like half a second. to take
Okay.
these ones.
A lot of them go very quickly, but also, I gave you a lot so that you could practice what you need to practice. Maybe go through and do all the odds first and check those. If you're getting all those right, don't bother doing the evens, okay? Here, 37 through 56, all of those, you're expanding those to multiple logarithms. On 59 to 76, you're condensing them down to one logarithm, Okay, so again, maybe do all the odds. If you get all those right, then don't do the evens. Okay. Here's one where they're using kind of an application. This is kind of an interesting problem if you read it. But anyways, I'm going to give you the remainder of our time to get started on these. I want you can either work on the board or you can work at your desks, but you must be working on this. Okay?